In this video, I will share some very important points about an equipotential surface. First of all, question arises, what is the meaning of equipotential surface? Means definition of equipotential surface. As the name implies, it is a surface at every point of which value of electric potential is same, and this surface lies in the electric field of some source charge. Means we can define it is a surface at which potential remains same. And equipotential surface may be plane and it may be curved depending upon the nature of source charges. If the source charge is a point source charge, then equipotential surface is spherical in shape. For example, if I take this point as point source charge, around it we can draw a surface of spherical shape at every point of which electric potential will be same. Next point is that there may be any number of equipotential surfaces. Means for a given source charge, number of equipotential surfaces is not limited. We can draw any number of such surfaces at every point of which value of electric potential is same. So I have drawn so many equipotential surfaces around this point source charge. Next property of equipotential surface is that stronger the electric field, more will be concentration of equipotential surface. Concentration of equipotential surfaces. So what is the meaning of this property? Suppose I have this point source charge. As we know, as we move away from this equipotential surface, electric field goes on decreasing. And when we are near the source charge, electric field is strong. When we are away from the source charge, electric field is weak. So this property says near the point source charge, there will be closer and closer equipotential surfaces. Means density of equipotential surfaces is more near the source charge and less as we move away from the source charge. This is the meaning that stronger the electric field, more will be concentration of equipotential surfaces. Next property I want to share regarding equipotential surfaces is that for a given source charge, its two equipotential surfaces can never intersect with each other. Never intersect. In order to prove this property, let me take an example. Suppose the equipotential surfaces of a given source charge intersect with each other. I will prove contradiction to this supposition. So at the point of intersection, if this surface has a potential value V1, this surface has potential value V2, then if they intersect, then this at this point of intersection there will be value of potential equal to V1 according to this surface. At the same point, value of potential will be V2 in accordance with the second potential. And it is not possible that at a point there are two values of potential. So our supposition that the surfaces intersect is wrong, means two equipotential surfaces can not intersect with each other. Next property is no work is done when we move a test charge on an equipotential surface. When test charge is moved on the equipotential surface. Again, how to prove this property? Let me take an example. Suppose this is an equipotential surface. I am moving a test charge from point A to point B. Test charge being moved over the surface. Suppose test charge is Q naught. So according to definition of potential difference, we know potential difference between point A and point B is defined as work done in moving the test charge from point A to point B divided by the magnitude of test charge. So using this definition of potential difference, I can write WAB is equal to Q naught multiplied with VAB. Now by definition of equipotential surface, potential at A is equal to potential at B. So potential difference between point A and point B is 0. So using this idea, I can write work done from A to B is 0. So that is the proof of this property, that when a test charge is moved over an equipotential surface, then no work is done. Last property I want to share regarding equipotential surfaces is that electric field lines due to a source charge are always perpendicular to equipotential surface. So what is the meaning of this? Suppose I have equipotential surface due to some source charge. Suppose this is point source charge. This property says that electric field line due to this source charge, let me take plus Q, this electric line of force. So this will be always perpendicular to surface, means perpendicular to tangent to surface if the surface is curved. If surface is plane, then it will be directly perpendicular to the equipotential surface. Now how to prove this property? For proving, let me consider the relation between potential difference and electric field. Potential difference and electric field. We know line integral of electric field between 2 points A and B, say, is equal to potential difference between those 2 points. This is the relation. And for an equipotential surface, suppose this point is A, this point is B, potential at A is equal to potential at B by definition of equipotential surface. It means potential difference between A and B is equal to 0. By using this idea in previous equation, I can write integral E dot dl vector from A to B is equal to 0. Means E vector dot dl vector is equal to 0. This means E dl cos theta is equal to 0. This means cos theta equal to 0, that is theta is equal to 90 degree. Means electric field and dl are perpendicular to each other. What is the meaning of dl? dl is a small displacement, small distance on the equipotential surface. So this property says that E vector is perpendicular to this dl or the given equipotential surface. That's all.